So today we're going to look at another technique of integration. So let's say that we were presented with the integral of x times cosine x, and we wanted to figure out what this integral was. That is, what function did I take the derivative of in order to get this? So one of the techniques that we've learned so far is u substitution. And remember that was the undoing of the chain rule. And here I don't really see the chain rule being at work here. I should see an inside function and its derivative, and I don't really see that. So it's not really going to work for us. But one thing that I do see is I see that this is a product of two functions. So maybe the product rule was at play in taking the derivative to get this function. So let's see if we can come up with an undoing of a product rule. So remember from Calc 1 that if I have two functions that are multiplied by each other, and I'm going to use, I know in Calc 1 we probably used f and g, but I'm going to use u and v and say that u is a function of x and v is a function of x. So if I had those two multiplied together and I wanted to take the derivative, so prime, remember that the product rule was the first thing, which is u, times the derivative of the second, v prime, plus the second, v, times the derivative of the first, which would be u prime. Okay, so this here is the product rule that we learned from Calculus 1. So since I want to figure out how to undo this, let's go ahead and take the integral of both sides, the integral of both sides with respect to x. So I've got my u v prime, integrate that with respect to x. And then I know that since these are being added together, that I can break that apart and make it the integral of the first thing plus the integral of the second thing. Okay, so I just took the integral of both sides. Now notice here that this is a derivative, right? I'm taking the derivative of this product. I'm taking the derivative and then I'm taking the integral. And remember from the fundamental theorem of calculus that those two undo each other. So on the left side here, all I'm going to get is u times v. Again, the derivative and the integral, those undo one another, giving me just u times v. Over here, though, I don't have just one set prime, right? The v is being taken the derivative of, but the u isn't. So I can't really simplify anything on the right over here. Okay? Now, notice that one of these things is kind of like what I have up here. So I'm going to go ahead and solve for one of these, just so I have it on one side. I'm going to go ahead and subtract this one here from both sides. So I'm going to subtract the integral of v u prime and subtract it from this side as well. Okay, so that would give us then on the left uv minus the integral of v u prime equals, and I would just be left with this piece over here. Okay, and I'm just going to go ahead and rewrite this because, again, what I have started out with is this, which kind of looks like this. So I'm just going to rearrange this so it's on the left instead. So I have u v prime equals u v minus the integral v u prime dx. All right, now this might not look like much, but it's going to be a really great tool for us to use when we're trying to find an integral of something that had, the product rule was used to take the derivative in the first place. This is called integration by parts. Okay, so we can use this to help to undo the product rule and figure out what an integral is of something like this, okay? And notice here that if I were to take the derivative of both sides, I would just get the product rule right back. I'd have uv prime, that was if I did the derivative here, the derivative of the product, which is this, here's that uv prime, and then the derivative of this would be vu prime, just added to the other side. So you can see I ended up getting the same thing. Okay, so let's go ahead and look at this one that we were trying to get in the first place, the integral of x times cosine x dx. Okay, so it's called integration by parts because there are really two different parts here. There's a u and there's a v prime. Okay, so let's figure out what we want to, we essentially are going to pick what we want to be u and what we want to be v prime. Now notice I have two pieces here as well. I'm going to go ahead and pick this part as the u and pick this part as the v prime. And you'll see why I picked it that way in a second. Okay, so I said, well, let's make u x and let's make v prime cosine x. Okay, so notice what we want to get here. I know what u is, I know what v prime is. So let's take a look at our pieces here. Start with u. Okay, I know that one. That u is x. Now I need to multiply that by v. Now notice I don't know what v is yet, but I do know that v prime is cosine. So that means that the integral of cosine, the antiderivative, is going to be v, right? V prime is cosine, so v must have been sine. The derivative of sine gives cosine. There's my v part, just filling in piece by piece, minus the integral of v, which I just found. V is sine. And then I need to multiply by u prime. Notice I don't have that yet, so let's go ahead and find it. I know that the derivative of x with respect to x is just 1, so times 1 dx. Okay, now again, this doesn't look like anything all that special, but notice what we have here. Here's the integral that I want, and now I've written it in terms of a function. So far, so good. And although I still have an integral, do you see how it's a much easier integral to evaluate than the one I started out with? Okay, so notice I can rewrite this as x sine x minus, now of course times 1 is just itself, so sine x dx. That's much easier to integrate than this first piece we had. So my final answer, x sine x, the antiderivative of sine is negative cosine. So I have a negative here, negative, negative, or positive. And then we'll go ahead and put that plus c, because I just integrated this indefinite integral. Okay, so that's our answer, x sine x plus cosine x. Now the beautiful thing about integration is that you can always check your answer by taking the derivative. If I take the derivative of my answer, I should end up getting what I started out with. And let's just go ahead and double check that that works. Okay, so notice I'd use the product rule here. That says I take the first thing times the derivative of the second, cosine, plus the second times the derivative of the first, which is 1. And then I have, so that was just the derivative of this piece. The derivative of this, derivative of cosine, is negative sine. So notice I have sine minus sine, and I'm left with x cosine x, exactly what I started out with. Okay, so we just undid the chain rule, or sorry, the product rule. So let's go ahead and try another one. Okay, we'll go ahead and call that example A, call this one B. Okay, so let's try again. Let's look at the integral of x squared times sine of x dx. A little bit similar, but again, I want you to notice that we can't use u substitution here because there isn't really an inside function going on. If these actually were switched, if this was an x squared and if this was an x, that would be a u substitution and not an integration by parts. Similar here, if this was an x squared instead of an x, then I would see a composition and its derivative, and we'd use u substitution. Okay, but I'm not getting that here. So let's go ahead and use integration by parts. Now here's some tips for using this, this method. Choose u so that u prime is simpler. Okay, so notice here I chose x to be u because the derivative of u is more simple than x. It's 1. Okay, and then a second tip that I have is choose v prime so that v, and v is the integral of v prime, is known. Okay, if you can't find the antiderivative of v prime, it probably shouldn't be v prime. Okay, so with that in mind, I want you to think about which of these should be the u and which of these should be the v prime. Okay, so hopefully you can see that x squared should be the u. Okay, because if I do that, then the u prime is going to be simpler. And if I pick the sign as v prime, I do know what the integral of sine is, so that seems like an appropriate choice. The great thing about this also is that if you choose wrong, you're going to find out pretty soon, because the integral that you have over here will be more difficult than this integral, and you'll know that maybe it wasn't the best route. So then you can just go back and switch it. Okay, so I picked u to be x squared and v prime to be sine x. Okay, so as opposed to up here where I just went piece by piece, depending on which one I needed, I know that I'm going to need u prime, and I know that I'm going to need v. So let's just find those to start with. If u is x squared, then u prime is 2x. And if v prime is sine, then v is going to be the antiderivative of sine, which is negative cosine. Okay, so let's fill in those pieces. So I have uv, x squared, negative cosine x, uv, minus the integral of v u prime. Okay, now let me just go ahead and rewrite what I have there. I have x, well, let's pull that negative out, x squared cosine x, and notice I have a minus minus, so we'll make that a plus, and I have this constant. I'm going to go ahead and bring that constant out in front. So that gives me, I'll write it this way, x cosine x dx. Okay, so just a little bit simplified. Now notice that this is still not something that I can automatically get the antiderivative of, although it is simpler than what we had started out with, because now I went from an x squared to having an x. Okay, so what we're going to have to do is we're going to have to do integration by parts one more time, and I'm going to write that as IBP, integration by parts again. But I would like you to notice one thing also is that we've actually already integrated this using integration by parts. That was the one that we just did. So just for the sake of saving time, let's go ahead and jump down to our answer. But if we didn't have this from before, we would use integration by parts again and pick our u and pick our v prime. Okay, so I have 2, and then from up here, x sine x plus cosine x plus c. Okay, so sometimes you'll have to use integration by parts more than once. Okay, so now if this was an x cubed instead of an x squared, how many times do you think we'd have to use integration by parts? Well, with the x squared, I had to use it twice, didn't I? Once and then twice. So if it was an x cubed, I'd have to use it 3 times. Okay? All right, so let's go ahead and try another example. Let's go ahead and do a definite integral this time. So let's say I wanted the integral from 0 to 1 of x e to the 2x dx. Okay, x e to the 2x, and I want to look at the area from 0 up to 1. Okay, so again, I hope that you can see that this is going to be an integration by parts. Usually a good sign of that is I see a product and I don't see a composition and its derivative. Okay, and although I do have a composition here with the 2x, its derivative, which is 2, is not down here anywhere. I have an x. So we're going to have to use integration by parts again. So let's go ahead and do that. And notice that what I'm going to want to do is I'm going to want to choose x to be the u. Again, that's usually pretty common. And then I want v prime to be the other thing, which in this case is e to the 2x. Okay, so I have u is x, v prime is e to the 2x. And so we'll find u prime. I get 1. And v, I'm going to go ahead and write it out this time. V would be the integral of e to the 2x dx. Okay, and we've talked about this a little bit before. This would be 1/2 e to the 2x. Okay, remember this 1/2 comes from the division of this number here. And essentially it's like doing u substitution. Notice if I took the derivative of this, I would have the derivative of, it's a chain rule, so I'd have derivative of the outside, which would be e, evaluated at 2x times the derivative of the inside, which would be 2. Notice I don't want that 2 there, so I put the 1/2, so it cancels. Okay, let's go ahead and write this out. So I have u, v, minus the integral of v, u prime. And notice here that u prime is just 1, so I don't really even need to write it in there. Okay? And notice one thing here. I have on the left, this is the definite integral. Okay, and notice with what I have on the right here, this is representing an indefinite integral. And that's a problem because those two are not equal to each other. So we need to actually evaluate this one. So this piece, I can say I want to evaluate that part from 0 to 1. And then this piece, I'm going again from 0 to 1. So unlike u substitution where I need to actually change the bounds, I don't have to do that here because everything is still in terms of x. Okay, so let's finish this one up. I have 1/2 x e to the 2x minus, I've got the 1/2 from here. And notice if I integrate this again, I'm going to get 1/2 e to the 2x again. And no plus c this time, since it's a definite integral. So I want to evaluate that from 0 to 1. And let's go ahead and plug that in. So I have 1/2 times 1, e to the 2 times 1, so e squared, minus 1/4, e to the 2 times 1, minus, this is the FTC1. Now we're going to plug in 0. Now notice this first part is going to be 0 because I have this x here. But the second part is not going to be 0. I'll have 1/4 e to the 0, and e to the 0 is 1. Okay, so let's go ahead and simplify this. I have 1/2 e squared and 1/4 e squared, so those subtracted would give me 1/4 e squared, minus a negative 1/4, so plus 1/4. So this would be my exact area. This is an exact number. And the approximate area, if I use my calculator, I get 2.097. So this is the approximate area. Okay, so again, integration by parts, we're going to use it to undo the product rule. And really the trickiest part is figuring out which one should be u and which one should be v prime. But again, if you choose wrong, you can always switch, so keep that in mind.